This video is explaining the concepts in Chapter 5, which is all about elasticities. So a few terms that we're going to cover in this section. Elasticity, what that means. There are three types of elasticity: own price elasticity, income elasticity, and cross price elasticity. And then that term price flexibility is related to some of these terms as well. So from Chapter 4, if you recall, we learned that demand for a particular product can change. It can increase, demand can decrease as a result of a variety of things. Demand for an item can increase or decrease due to a change in price. So if the price of the good increases, likely the demand for that good will decrease. The demand can change if the income of the consumer changes. So for a normal good, if the income of a consumer increases, their demand for a particular normal good would likely increase. And consumer demand can also change if the price of other goods, complements, or, sorry, this should say substitutes. Complements or substitutes changes. So those were the examples with Coke and Pepsi. So Coke and Pepsi are considered substitutes. And so if the price of Coke increases, the demand for Pepsi may increase because it is now a cheaper price than Coke. And then also demand can change if tastes and preferences change. And we went through lots of examples about what can happen if advertising campaigns are really successful, or if a foodborne illness, if there's a foodborne illness that breaks out, and how that can change demand of specific products. So we learned in Chapter 4 that consumer demand can change as a result of these four things, but what we have not yet learned is how much do these things influence the change. So if things change a lot, if demand changes a lot with just a small change in price, we're going to say that that good has a low elasticity. If demand changes just I think I worded that wrong, I'm sorry. Let me rephrase that. If a demand changes just a little bit in response to a large change in price, that's a low elasticity, and we often call that inelastic. And if demand changes a lot with a small change in price, we call that good very elastic. So we'll get into the details about that a little bit more here. We can measure elasticity based off of in three different ways. So we know that demand can change in four different ways, as we saw in the previous slide, but we're going to look at three of those ways. So the first way is demand can change if the price of that particular good changes. So we have a particular equation to calculate own price elasticity. This is going to be a ratio, and it's going to tell us how sensitive demand is and how much demand will change if the price of a good at hand changes. Okay? Income elasticity measures how sensitive a demand is and how much demand will change if the income of a consumer changes. And then similarly, cross price elasticity measures how much the demand will change if the price of a substitute or complement good changes their price. Okay? So we're going to look at each of these, and the equations are similar but different, and we're going to be able to calculate a value for each of these elasticities. So our first equation that we have here is for the own price elasticity of demand, and it is a ratio of percents that answers the following question. It answers, what effect will a 1% change in price have on the quantity of the good that is demanded? So basically, if this value is equal to negative 1.8, which own price elasticity of demand are always negative. What we can assume from that then is that if there is a 1% change in the price, increasing or decreasing, there will be a 1.8% change in demand. So if there's a 1% increase in price, there's going to be a 1.8% decrease in demand. That's what the negative stands for there. Similarly, if there was a drop in price, so I'm writing the negative here, negative 1% drop in price, there would then be a positive 1.8% increase in demand. So that is what own price elasticity tells us. Okay, so here is our first example. We have the equation up here for own price elasticity of demand, that is the percent change in quantity divided by the percent change in price. Well, how do we calculate the percent change in quantity? The equation for the percent change in quantity is right down here, and that is Q2 minus Q1 divided by the average Q. Okay, then we're going to divide that whole answer that we get from that and divide it by the percent change in price. The percent change in price equation is listed right here. P2 minus P1 divided by average P. And this is going to give us something. And then we're going to take those two values and divide them. So let's do that really quick for example number 4. The own price elasticity of demand for shrimp between points A and B is, okay, so we're going to call A our Q1, and well, that'll also be our P1. B, we're going to call that our Q2 and our P2. So we need, for the first part of the equation, our Q2, so point B. So our Q2 quantity is down here, is 50, minus Q1 quantity is down here, 20, divided by the average of Q. Well, the average of Q, we only have 2 Q quantities, so 20 plus 50, which equals 70, divided by 2 equals 35. So the average of 20 and 50 is 35. So we're going to divide that by 35. I'm going to grab my calculator. I'm going to take 50 minus 20, which is 30, divided by 35, which is 0.85. Okay, so that's the number that I have on top here, 0.85. I'm going to circle that so we know. Okay, and then we're going to divide that by whatever the value is for the percent change in price. So P2, price of the second option is $5 minus P1, which is $8, divided by the average of P. So average of P, 5 plus 8 equals 13, divided by 2 to get the average is 6.5. So we're going to divide that by 6.5. So we have 5 minus 8 equals negative 3 divided by 6.5 equals negative, I gotta erase some of this, I'm sorry. .46. So now we're going to take 0.85 and divide that by 0.46. 0.85 divided by, well, it's negative 0.46, and we're going to get negative 0.39. That is not the right answer. I didn't type that in correctly. Okay, let me try again. I'm going to type in 0.85 divided by 0.46, and it's actually 1.8. So that matches our B answer, negative 1.8. Okay, so hopefully you guys can get that correct on the quiz. We'll do one more example here. So the own price elasticity of demand for oranges at the farm level is negative 0.3. Suppose that an unexpected freeze occurs resulting in a 6% drop in orange production. Orange prices will, what will they do? Okay, so let's start with our equation. So our own price elasticity equals percent change in Q divided by percent change in P. Percent change in Q equals Q2 minus Q1 divided by average Q, and divide that by P2 minus P1 divided by average P. Okay, so let's see what we can plug in. The own price elasticity of demand for oranges at the farm level is negative 0.3. So they gave us the own price elasticity. A unexpected freeze results in a 6% drop in orange production. So that means they're talking about the percent change in quantity. So we have a negative 6%. And we do not know the percent change in P, but that's what it's asking. Orange prices will do what? So actually, we don't even have to look at that part of the equation because the percents have already been figured out. So all we need to do here is cross multiply and divide. So in order to, we need to figure out what number we can divide 6% by to get 0.3. So I just cross multiply and divide up. So I go 6 times 1 equals 6, and then I divide that by negative 0.3. Let me put that on my phone. 6 divided by negative 0.3. And I get a positive 20%, or a negative, I'm sorry. No, it is positive because I forgot to bring my negative with the 6%. So negative 6% should have been negative 6, and then we're dividing a negative by a negative. So that's going to be a rise by 20%, which makes sense that if the demand has decreased, or if the production has decreased, so the supply has decreased, the price will rise by 20%. Okay, so now we're going to look at interpreting the numbers that we get. So we label these values as being elastic, inelastic, or unitary elastic. And I briefly alluded to this in the beginning, but if a 1% change in price causes a greater than 1% change in demand, so if we change the price by 1%, increase it by 1%, and that decreases the demand by 1.8% or 2% or 3%, that's greater than 1%. So we call that elastic. That means it's responding greatly to a 1% change in price. Oppositely, if the own price elasticity is less than 1, then we say that the good is inelastic. This means that a 1% change in the price will cause less than a 1% change in demand, so the demand does not respond as much to a change in price. So the consumers are not very responsive to a change in price. And if a 1% change in price causes a 1% change in demand, we say that that good is unitary elastic. So it will change, the demand will change at the same rate that the price is changing. Okay, if a good is inelastic, consumer demand for the good does not change very much, even if the price increases or decreases, as I said up here. I just want you to think for a second, is there a good that is inelastic, that it doesn't matter what the price is of that good, but you as a consumer are probably going to buy the same amount of that good? Some things that I can think of are toilet paper. It probably doesn't matter if toilet paper is $10 a pack, $2 a pack, or $20 a pack. You're probably going to buy the same amount because you only need a certain amount and you need that amount. So there are other like staple products that you might be able to think of that no matter whether the price raises or lowers, you are going to probably buy the same amount. Bottled water might be one of those as well. You know, kind of some of those necessities are things that tend to be inelastic. Okay, something else to note about the own price elasticity is that there's not a single own price elasticity for a particular product. The own price elasticity changes along different points of the demand curve. So let's prove this by finding the own price elasticity at each of these points. So the first point, let's just label these A, B, and C. And let's find those points on this graph. So a price drop from $9 to $8. Quantity demands increases from $2 to $3. So there's where our 2 meets our 9 and our 3. So these are our 2 points on the demand curve. Okay, so the price elasticity between these 2 points, let's figure out what that is. Okay, real quick, we're going to try to calculate these own price elasticities. So I might do this kind of quickly, and you might have to review the equation to get it all. But I'm going to actually summarize, or I'm going to shorten percent change in quantity divided by percent change in price. That triangle means change in. And recall that the top part of this is change in quantity divided by average quantity. That line above the Q is average. And then the bottom, change in price divided by average of price. So our change in quantity for the first one, we're going from 2 to 3. So the change is 1, because we could do 3 minus 2, that's 1. We're going to divide that by the average. Well, the average of 2 and 3 is 2.5. Okay? And we're going to divide all of that by the change in the price, which is 8 minus 9, which is negative 1. And recall, own price elasticities are always negative. So sometimes we leave those out because they're always negative. So 1 divided by 2.5. And then on the bottom, we have 1 divided by the average of P. Well, the average of P between 8 and 9 is 8.5. So if we calculate that out, 1 divided by 2.5 is 0.4. And then if we divide that by 1 divided by 8.5, 0.12. And then we divide 0.4 divided by 0.12. We get a 3.33. So the own price elasticity up here is, from here to here, is 3.33. And we note, as the chart says, that it is greater than 1 at this point. So at those price and quantity points, this item is elastic because the own price elasticity is greater than 1. Okay, I'm going to erase the last part of this and we will quickly calculate the next two. So for B, the price drops from $6 to $5 and the demand increases from 5 to 6. So 6 to 5 is the change in quantity. So that's 1 divided by the average, which is 5.5, divided by change in price, which is 1 divided by the average of P, which is also 5.5. We can probably already predict what this is going to be, but we'll calculate it out just for fun. 1 divided by 5.5 equals 0.18. 1 divided by 5.5 equals 0.18. 0.18 divided by 0.18 equals 1. So at this point, where we went from $6 to $5 and from quantity of 5 to a quantity of 6, own price elasticity equals 1. So own price elasticity equals 1 where it is unitarily elastic. Okay, real quickly, let's do the last one. So we have, at this point, price drops from $3 to $2. And demand increases from 8 to 9. So demand goes from 8 to 9, that's the change in quantity is 1. The average quantity is 8.5 divided by change in price, which is 1 from $3 to $2, divided by the average price, which is 2.5. So we have 1 divided by 8.5, 0.12, 1 divided by 2.5, 0.4, 0.12 divided by 0.4 is 0.3. So 0.3. This own price elasticity is less than 1, so we're going to call this inelastic. Okay, so why does this matter? Depending where you're at on this demand curve is going to depend if you will make more money by increasing your price or lose money by increasing your price. So let's take a look at the next. Okay, so real quick, I'm going to write in the, this was 0.3, this was 1, and we had, at this point we had 3.33. So we can see that the own price elasticity is increasing. As we raise prices. Okay, so let's go ahead and calculate the revenue at each of these price points. So if the price is $1, our revenue, we are going to sell 10 items at $1. So our revenue is $10. Our revenue at $2 is 2 times 9, which is 18. Our revenue at $3 is 3 times 8, which is 24. Our revenue at $4 is 4 times 7, which is 28. Our revenue at $5 is 5 times 6, because we're selling 6. So that's $30. Our revenue at $6 is 6 times 5, which is $30. Revenue at 7 is 7 times 4, which is 28. At 8 is 8 times 3, which is 24. $9 is 9 times 2, which is 18. $10, 10 times 1, which is $10. 11 is 0. Okay. So what does this mean? This means that, first of all, our maximum revenue and profit occurs when own price elasticity equals 1. This is that $5 to $6 range. That was the same point that we had everything equaling 1. That also means that if our own price elasticity is less than 1, so here our own price elasticity is less than 1, we want to, let me actually write this down for you. This is important, you can write it down too. If own price elasticity is less than 1, firm wants to raise price to increase revenue. However, if own price elasticity is greater than 1, I should say elastic, then firm should decrease price to increase profits. Okay, so we can see that because the maximum profit is here. So when something is elastic, you're going to want to decrease the price of the product to increase profits. When something's inelastic, you're going to want to increase the price of the product to increase profits. Okay, so let's fill in the blank to see if we actually got this. Within the elastic section of the graph, so that was the high section, this was elastic, this was unitary elastic, and this was inelastic. So within the elastic section of the graph, an increase in price will decrease the revenue of the firm, because the higher that we got up on here, the lower our dollar went. So the firm would want to decrease the price of their product because they don't want to decrease the revenue. So if an increase is going to decrease the revenue, they actually want to decrease the price so they can increase the revenue. Within the inelastic section, so that was the bottom section, an increase in price will increase the revenue of the firm. So the firm would want to increase the price of their product. Okay? When the product price decreases, own price elasticity, so remember we have our price over here. So as price is decreasing, the elasticity, so on each of these points as it's decreasing, the own price elasticity is also decreasing. Because remember we went from 3 to 1 to 0.3. And the good becomes more inelastic. Okay, we have that written there too. And then when the product price increases, own price elasticity increases. Because as we go up, that increases and the good becomes more elastic. Okay, if some of that was unclear, I would go back and look at the previous slide and look at the chart, and as you look at the chart and the graph together. So here's an example of a problem that you'll come across in the quiz. If own price elasticity of demand is negative 1.25, so recall all of them are negative, so don't need to pay too much attention to that. But if it's 1.25, so it's in the, if it's greater than 1, it's going to be elastic, right? Then we have our unitary elastic portion, and then we have our inelastic. And price 0 to, let's just say 10. So if the own price elasticity of demand is negative 1.25, so that's 1.25, so we're in the greater than 1 section, so we're elastic up here. In order for the manufacturer of Ragu to increase total revenue, at least in the short run, it would be advisable to, well, we can tell, we don't want to do nothing. If we raise the price, we're getting a smaller and smaller profit. So we want to lower the price of Ragu, because if we lower the price of Ragu, we're going to go down closer to unitary elastic, which would be a larger revenue in the long run, or in the short run. Okay? So here's an example of what a graph would look like if it was perfectly elastic, and also what a graph would look like if it was perfectly inelastic. So if a good was perfectly elastic, that means it responds. So remember, elasticity, if something's elastic, it's going to respond to a slight change in price. And if something is inelastic, that means it does not, so demand does not respond to a change in price. So we can see here that the price is increasing, from 0 to, let's say, 1,000, who knows. The quantity demanded is going to stay exactly the same in a perfectly elastic demand curve. There's probably not an item out there that is perfectly inelastic, because at some point something's going to get too expensive for anybody to be able to afford. Although I would say, let's say we had to all buy water, that might be something that you would spend everything on because you can't live without it. Although you might try to find other ways to get water. But let's say the only source of water was through bottled water, you'd probably spend everything on it to have it. Okay, and then similarly, or oppositely, elastic goods respond to just a very slight change in price. So like this is actually showing, there's no change in the price, but let's just pretend we're going from like $1 to $1.01. A perfectly elastic good would change tremendously the amount of quantity that is demanded just by a very, very small change in price. Again, not very realistic, but more like a graph is going to look like that if it's elastic, and a inelastic graph is going to look like that. Okay. Okay, so here is another term that we can look at, price flexibility. It's basically the reciprocal of own price elasticity, which instead of saying, so for own price elasticity, we're saying given a 1% change in price, how much quantity demanded change. For price flexibility, we're answering given a 1% change in quantity demanded, how much can price be changed? So it's the complete reciprocal opposite. So instead of, where our own price elasticity equation is percent change in quantity divided by percent change in price, price flexibility is percent change in price divided by percent change in quantity. So if the own price elasticity of demand equals 0.2, negative 0.2, that would be all over 1, right? Then the price flexibility of demand is equal to what? Well, our percent change in quantity is negative 0.2, and then our change in price is 1, so we just flipped it. We went from negative 0.2 divided by 1 to 1 divided by negative 0.2. So I'm going to take 1 divided by 0.2 and put the negative sign in it, and that's going to be negative 5. Okay, so number 10, the answer is C, -5. Okay, we spent a lot of time on own price elasticity. So we're moving on to income elasticity. So income elasticity is the equation is somewhat similar, but we are asking and answering the question, what effect does a 1% change in income have on quantity demanded? So we have the same part of the first equation, the percent change in quantity equals change in quantity divided by average quantity. But the bottom, instead of being percent change in price, it's percent change in income. So let's go ahead and see if we can try number 5 here. So what is the income elasticity of demand for pizza between points A and B? So A is going to be our 1, B is going to be our 2. So change in quantity divided by average quantity, and divide that whole thing, divided by change in income, divided by average income. So our change in quantity is, we're going from 6 to 2, so 6 minus 2 is 4, and we're going to divide that by the average. So 6 plus 2 equals 8, divided by 2 equals 4, so the average of 6 and 2 is 4. 4 divided by 4 equals 1. Okay, and then we have the change in income. So we have 60 minus 40. And you can see here, 60 minus 40 is 20. So let's just write that in there. Divided by the average income. So 60 plus 40 divided by 2, that's 100 divided by 2, which is 50. So 20 divided by 50 is 0.4. Now notice this time it's not negative, okay? So we do have to pay attention to negative signs with income elasticity. So we have 1 divided by 0.4, and that is 2.5. So the answer there is C. We'll talk about what the positives and negatives mean in a bit. Right now, we're going to talk about what positives and negatives mean. Okay, so when an income elasticity is greater than 1, we say that that good is a luxury good. That's a term we haven't had yet. This means that if income increases by 1%, the demand for the good will increase by more than 1%. And same for decrease. So if the income decreases by 1%, demand for the good will decrease by more than 1%. A normal good, the income elasticity is less than 1 but greater than 0. So those are going to be your positive decimal points. So if you have a 0.5, 0.75, those are going to be normal goods. So this means that if an income increases by 1%, the demand for the good will increase by less than 1%. But this increase tells us that it is still a positive number. When income elasticity is less than 0, the good is an inferior good, which means that if income increases, demand for the good will decrease. And we kind of talked about those in chapter 4. Okay, so here's an example according to the diagram. Monterey Jack cheese is what kind of good? Well, is it a luxury, a necessity, inferior, or can't we tell? Well, we got to do the math, right? So income elasticity, we have to write out the equation, which is the percent change in quantity over the percent change in income, which is actually the change in quantity divided by average quantity divided by change in income divided by average income. So change in quantity. So let's just do a and a B or a 1 and a 2 here. Change in quantity goes from 70 to 50. So that's a difference of 20 divided by the average. Well, the average of 50 plus 70 divided by 2 is 60. And we'll divide that by the change in income, 80 to 60. Well, in this case, okay. So again, 80 minus 60 is 20,000 divided by the average of the two, which is 70,000. All right, we got to just make sure we're still subtracting the correct thing so that we're getting the right negatives. So we did the 2 minus the 1s for all of them. Okay, so now we can calculate this out. 20 divided by 60 is 0.33. And then 20,000 divided by 70,000 is 0.286, we'll say. And then if I do 0.33 divided by 0.286, I get 1.15. This number is greater than 1. So we know from the previous slide that this is a luxury item. The final equation that we need to look at is cross-price elasticity. Very similar to the other equations. This time, however, we are answering the question, what effect will a 1% change in price of a different good have on the demand for the good at hand? So we're looking at the equation, and it's the percent change in quantity A divided by the percent change in price B. A representing the good at hand, and B representing that different good. The different good may be a complement good, it may be a substitute good, or it may be an independent good. And if you call those definitions, well, we'll review those definitions shortly. But first, let's look at this practice problem, number 23 down here. So it says, suppose that a retailer sells 500 six-packs of Dr. Pepper per day at $3.50 per six-pack. Also, suppose that the cross-price elasticity between Dr. Pepper and Pepsi is 0.6. If the retailer lowers the price of Pepsi from $4 to $3.60 per pack, what is the percentage change in the price of Pepsi? Okay, so in order to do this one, we're going to do a couple steps here. So first, we know that the cross-price elasticity is 0.6. So I'm going to actually erase this up here so that we can just plug it into this calculation. So we know that the cross-price elasticity is 0.6. So we have 0.6 equals percent change in quantity A divided by percent change in price B. So actually, what they are looking for is this value. In order to find this value, we have the equation here. Price of B2 minus price of B1 divided by average price of B. So they gave us a little bit too much information to try to confuse you, so you don't even really need the cross-price elasticity. We do need the second price for B, which it tells us here. They lowered their price from $4 to $3.60, so they did do $3.60 minus $4, and we need to do it in that order, divided by the average. Well, the average of $3.60 and $4 is, if you add them both together and divide it by 2, it's going to be $3.80. And then we can put that in our calculator. So $3.60 minus 4 is 0.4 divided by that 380. And that's going to equal negative 0.5. Okay. So we get a decimal number. You just multiply that 100 by 100 to get the percent. So that's going to be about 10.5%, but remember the negative. So it's going to be a decrease because it's a negative. So the answer here is a 10% decrease. Okay, one more here. Assume that a retailer sells 800 six-packs of Dr. Pepper per day at a price of $3 per six-pack. You, as an economic analyst, estimate the cross-price elasticity to be 0.6. So we have cross-price elasticity equals percent change in quantity A divided by percent change in price B. 0.6 is the percent change, or is the cross-price elasticity. Retailer raises the price of Coca-Cola by 10%. How would the sales of Dr. Pepper be affected? So they raise them by 10%. Okay, 10%. We got to change that to a decimal to cross multiply and divide. So we want to know what this is going to do to quantity A. So if we take 0.6 times 0.1 and then divide that by 1, we will get 0.06, so that's 6% change. So that's a 6% change. And we started off with the retailer sold 800 six-packs. So we have to figure out what a 6% change of 800 is. So 0.06 times 800 equals 48. All right, so is this going to rise or is this going to fall? We had a positive number, so it's going to rise, which makes sense because sales of Dr. Pepper would rise. This makes sense because if Coke increases their prices, Coke is a competing product, it's a substitute product, so the sale of Dr. Pepper is going to increase. Okay, similar to how we were able to interpret the values for income elasticity and own price elasticity, if the cross price elasticity of a number is positive, then the two goods are substitutes. So this means that a 1% increase in the price of a substitute good, so in that last case, I think it was Pepsi and Dr. Pepper. Pepsi was a substitute for Dr. Pepper. So a 1% increase in the price of a different good will cause an increase in the quantity demanded for that substitute good, and vice versa. If the substitute good price decreases, then the quantity demanded will decrease. If the cross price elasticity is a negative number, then the two goods are complements, which means that a 1% increase in the price of the complement good will cause a decrease in the quantity demanded for the good at hand. Same goes vice versa, meaning that if a 1% decrease in the price of a complement good, there will be a increase in the quantity demanded of the good at hand. So that's the effect that complements have on cross-price elasticity. And then if the cross-price elasticity is 0, we can determine that the two products are independent of one another and we talked about independent goods being like salt and ice cream. You don't eat ice cream with your salt, so a change in price of one's not going to affect another. The complements, if you recall, is like chips and salsa. So, you know, a decrease in the price of salsa may cause an increase in the price of chips. So here is a short video that you could click on this link to watch. And you can think about those questions, but I think it's a nice little, it's like a 2 or 3 minute video. You got to go to this website and then just scroll down to the video, and it kind of summarizes the concepts of elasticity. I think it might be helpful. If some things are a little bit fuzzy, it would be worth your time to watch. It's an animated, informative video. Other than that, always, as usual, feel free to contact me, and we will, I will help you out. You can contact me via email, and we can set something up if you need any help. Okay, good luck on the quiz and on the homework problems, and have a good week.